Hey, welcome my friends. Good evening. Welcome back to the sprint for grade 12th board exams. Today is day number 10th, and we are doing part 2 of modern physics today. So before we start, let's look at the schedule. The schedule which you've already seen many times. Today is day number 10. We are doing modern physics part 2, that is atoms and nuclei, the things that we and you and I and everything around us is made up of. So for students who have never been to the sprint here, for newcomers, this is Bhavdeep Sir. I am a physics master teacher here. I would recommend that after today's class, you go back and see the past 9 sessions that are freely available on YouTube. Subscribe to the channel, press the bell icon, because you have many good courses, fantastic courses lined up. They are going to come live in next few weeks. So make sure you press the bell icon so that you can get the notifications about those. Share the information about this channel with your friends, relatives, classmates and neighbors so that they can get advantage of the free education here. Please tell them there are awesome teachers, the best teachers in the country coming here giving you free education. Please do so, help them. So the strategy as always is going to be simplification. Any derivations, any concept that you thought were difficult because the books make you do long pages of understanding there, we are going to simplify them. No complications, only simplicity. That is the strategy for all the classes today and all the classes in this course today and going forward in the previous sessions. So why are board exams important? This is the 10th time I'm repeating that, because 75% marks are needed in your board exam if you're aiming for IITs, NITs or centrally funded engineering institutes. If your board gives percentiles, you have to be in top 20 percentile. For medical students, that is 50% in physics, chemistry and biology. But more important than that is board exams clear your concepts. They make you do derivations, long analysis and all that, but that is really helpful. You're learning physics and that is going to help you in the long run, not just in your career, in your life also. So competitive exams, very important, because they assure a seat in one of these schools and colleges, but this assures that you clearly understand physics. Board exams are a must for that. If not this, at least these two make you give very high importance to board exam preparation for next few weeks here. So what is in store today? Today we are going to study about all this: fission, fusion, radioactivity, atoms and nuclei. Very important chapter, very interesting chapter, 6 marks down there, and the key to understanding that is just one thing, that is going to be the binding energy. Whatever is highlighted here is the key for this topic. Rest 3 are common. Binding energy is the key here. Understand binding energy, nucleus is over. You understand everything in that. So all the derivations from the NCERT books have to be done, not just for exams, but to understand physics. But from exam point of view, all the derivations there. Take a plain sheet of paper, you should be able to derive anything yourself. In simple words, in simple steps. Binding energy, समझ जाओ, सब कुछ आ गया nucleus का. What is binding energy? Not memorizing what that is, understanding what is binding energy. NCERT back exercises, all the questions including additional questions have to be done without any help from solutions. You can refer to the solutions once in a while, try to completely do them yourself. Past 5, at least 5-year question papers must. Download the papers from Vedantu website. Try to solve them in your own way and then try to match them with the solutions or the marking schemes to ensure that what you're presenting is exactly what is expected from you. But do not take the solutions with the questions, because फिर रट्टाफिकेशन हो जाएगा. Then you're trying to memorize things. Physics is not about memorizing, it's about understanding. It's not going to help you if you take the question papers and the solutions. No, don't do that. Solve them yourself, then take the solutions and match that. So the right way for this chapter is understand the binding energy. ये एक graph है. This one graph is the key to the whole of the nucleus understanding. This graph master कर लिया अगर, तो you understand what is fission, what is fusion, what is radioactivity, why do nucleus break, why does it break, why do they combine. You understand because of binding energy, because everyone wants to go there at the highest point where the binding energy is maximum. बाइंडिंग एनर्जी मैक्सिमाइज कर रहे हैं वो. सो लेट्स ट्राई टू अंडरस्टैंड दिस अ लिटिल, क्योंकि कुछ क्वेश्चंस में काम आएगा. per nucleon. Nucleon क्या है? The residents of a nucleus. Protons and neutrons are nucleons. So on the x-axis you have the atomic number, right? Nucleon number. That's the mass number basically. So the number of nucleons is the mass number. So that's mass number and that's the energy per nucleon. तो जितना भी बाइंडिंग एनर्जी है उस न्यूक्लियस की, डिवाइड दैट बाय द मास नंबर, दैट गिव्स यू द एवरेज काइंड ऑफ, राइट? If you think about the tiny ones, and actually if you had been to one of my long-term courses, the year-long courses, you have already seen those. The way I explain that is क्यों ऐसा हो रहा है. अभी क्यों का टाइम नहीं है. We'll see what is happening, not why it is happening, because अभी थोड़ा सा time crunch है. At the bottom here you have tiny little atoms, hydrogen, helium and all that. But the main thing to understand here is as the mass number increases, the binding energy increases. More the binding energy, more the stability. अगर नहीं समझ में आता, there's a family here, the closely knit, the more binding they have, the more stability the family has. Think about that way. So if they have more binding energy, they're bound together closer with what more force now, and it's really hard to break that family. So more the binding energy, more the stability. And everything wants to go to a stable situation here. So as the mass number is increasing, the binding energy is increasing, it's going towards more stability. At a certain peak, as the mass number increases, and why so we don't have time for that, but for now understand, as the mass number increases, the binding energy starts reducing. But remember, everybody wants to have more stability, more binding energy. तो यहाँ पे छोटी छोटी दो न्यूक्लियस क्या करेंगे, मिलके बड़ी हो जाएंगी, राइट? दो हाइड्रोजन लिए, उनके पास कम एनर्जी थी, कम एनर्जी मिलके ज्यादा हो गई, एक से भले दो, right? That kind of scenario. So basically two hydrogens combine and they become one helium. And when they become one helium, they're rising up the ladder towards more stability. That is more stability. And when they do so, they release energy. और ये हो गया तुम्हारा fusion, nuclear fusion. Sun does that. On the other side, बड़ी nucleus थी, uranium 235, breaks into two parts. When it breaks into two parts, दोनों का mass number कम हो गया. तो when it breaks into two parts, they climb up the ladder, है ना? So they are going towards more stability now. So one big nucleus breaking into two, more stability, the energy is released as the kinetic energy of those neutrons. So breaking this big nucleus, that is nuclear fission. ठीक है? बाकी हम questions में देखते हैं. So there's a question number 1 here. Give any one difference between Thomson's model and the Rutherford model for an atom. 1 mark question. But this is something you have studied in your chemistry classes as well, right? So basically Thomson model talks about the plum pudding model. ना pudding है, उसके अंदर plums रखे हुए हैं. तो pudding is positively charged and there are plums that are negatively charged on that. That is what Mr. Thomson suggested. That is the way he visualized it. Within next few years, Rutherford and also came in Bohr after that, they said no, that model doesn't look good, and Rutherford suggested more like a planetary model. Just the sun के around planets revolve करते हैं, and he said okay, there's a nucleus here which is positively charged and there are electrons revolving around it. But there were flaws in that theory also, but that's not the question. The question is give one difference. This is one difference here. You got to understand everything here. You have to understand the Bohr model. Please make sure you understand Bohr model and also understand why Bohr model is also not accurate, because of all that Heisenberg uncertainty, because of dual nature. Electron cannot be predicted कि यहाँ है फिर यहाँ नहीं, it is all uncertain out there. So you have to go into that level. You have to understand these things and then you can present it in 1 mark question like this. पहले समझना है उसको. Redbird Constant. Okay, this is something you have already done that. If not, then you should be reading that. I will just cover the question here. So Redbird Constant gets proportional to z square. That's it. ना इसको ऐसे लिखना है. I'm just trying to show you. So that's proportional to the z square, where z is the atomic number. So when atomic number increases, the Redbird constant used over there is going to increase. Yeah, this is more like a fact-based question for now. Now this question, there is nothing to memorize here. The reason I'm saying, क्योंकि वैसे तो memorize करके एक line का like Redbird constant, but this is basically key to many things. So you have to understand the density of the nucleus is a constant. वो जो उसकी density है, what is density? Mass per unit volume is constant. You take any nucleus out there, You take hydrogen nucleus, you take uranium, you take iron, anything, the density is constant, mass per unit volume is a constant. तो उससे ये question हो जाएगा, but the reason I'm doing that is क्योंकि काफी other questions में भी ये concept use होगा. Density is mass per unit volume. This is a big constant. Please do remember that density of nucleus is constant. तो mass per unit volume की बात हो रही है. Volume क्या होता है? We are visualizing as a sphere 4 pi r cubed, 4 by 3 pi r cubed. So mass divided by 4 by 3 pi r cubed is a constant. Now 4 by 3 is a constant, pi is a constant. So all we are saying is now mass is proportional to r cubed, or you can say the radius is proportional to m ki power 1 by 3. The reason I did that is sometimes this is asked as a 3-mark question. Yeah, yes, right. So you're supposed to do this. But for this question, you just give this relationship. I'll show you how. So the radius is equal to the base radius there times atomic mass to the power 1 by 3. Because atomic mass is the mass you're talking about, mass per unit volume. So atomic mass, protons plus neutrons ka mass. एक number का question, you're supposed to write this. ज़्यादा का है, then you write more. है ना? So once you understand the concept, you decide how you have to present it. एक mark के question में you don't have to present a lot. In more mark questions, you have to present more. You have to also go behind the scenes. Why? अब ये पढ़ो, ये अगर पहला तुमने जो ग्राफ मैंने दिखाया था, if you have understood that, then it's a piece of cake. 4 nuclei of an element undergo fusion to form a heavy nucleus. With release of energy, which of the two, the parent or the daughter, would have a higher binding energy? पहले तो think about why would they unite? They would unite if it is more stability. Nature, the law of nature, things want to be stable. ये पेन छोड़ा नीचे आ गया, क्यों नीचे आ गया? क्योंकि यहाँ पे ज़्यादा stable था. Right, there is less energy now. Right, now binding energy, देखो सीधी सी बात है. Let me do this one more time. What I'm saying is there was potential energy, it's reducing energy. Everybody wants to reduce the energy content. Now binding energy on the other hand is a negative energy. When you're increasing that, you're basically reducing it. Bada negative number is less number. Think about that way. Now back to the question here. Why would they reunite unless there is a stability? There is more stability, means more binding energy. They reunited because the product will have more binding energy. But हो गया, खत्म हो गया. 4 न्यूक्लियस थी, उन्होंने चारों ने कंबाइन होकर एक बड़ी न्यूक्लियस बना दी. It's a fusion happening because there is more binding energy there. So look at the answer here. It's a 1-mark question. You're supposed to write this. So basically ये मैंने graph, I just put it again in case I have to explain one more time. So there are 4 tiny nucleus. They're combining to make bigger one, but when they combine to make bigger one, the mass number is more, means they're going towards more binding energy. So the final product will have more binding energy. I'll show you the sample response here. You don't have to memorize any of this. You have to understand every piece of it. Use your own words, your grammar, your vocabulary, and present yourself. You are unique. Your solutions have to be unique. At least your words have to be. So let's go to the next question here. State Bohr's postulate to define stable orbits in hydrogen atom. How does de Broglie hypothesis? So here's another thing. Rutherford said, okay, planetary model, but there were flaws. Because planetary model hai, the things are accelerating, centripetal acceleration. When a charge is accelerating, it is supposed to release energy. If it is supposed to release energy, its energy will reduce, and then it has to spiral back into the nucleus. And none of the things would actually be existing. I would not be there, you would not be there, this man would not be there, nothing would exist. No matter would exist here. Now Bohr came in and Bohr proposed that there are certain, he gave few postulates here and he said, okay, the electron can be in only a few given. So let me cover that a little because this is going to help you in future questions also today and otherwise. So what Bohr is saying, there is a nucleus with neutrons and protons and there are orbits here. So electron can be in this orbit or electron can be in this orbit. There is something special about these orbits. He is saying either this orbit or this orbit. बीच में नहीं ले सकते तुम. It's impossible. Now, what is special here? He is saying special here is the angular momentum, which is L, is an integer multiple of the Planck's constant by, or basically the reduced Planck's constant. That's what he is proposing. It's an integer multiple. As I was saying in yesterday's class, reduced Planck's constant, which is also written as h bar. And this is more useful in most of the situation. So he is proposing this. Now postulates, what are postulates? I'm proposing this is a fact, take it for a fact. I will not prove it. I'll not give you any reason for that. But just take it. So he's proposing this. Okay, these are stable orbits. Electron can be here or electron can be here. When they are in a stable orbit, there will be no energy released, and that is why it doesn't spiral in. And he is able to explain that. But kyun? He is not telling you that. And down the line comes de Broglie. When de Broglie comes in, he explains kyun. Postulates have basically no proofs or nothing. It is just a statement in there. So how does de Broglie explain that? So I'm going to show you the printed version of this solution, but just let's understand how simple this is. Now think about a rope. And a rope go up and down, there's a stationary wave that builds in there. Stationary waves are stable waves. There is no energy transfer in that. But what's special about them? The length of the rope has to be integer multiple of the wavelength. 1 wavelength, 2 wavelength, 3 wavelength, a million wavelength. But it has to be integer multiple. You cannot say this rope will have a standing wave and 1.35 wavelengths. No. It has to be integer wavelengths. Now when de Broglie is saying electron is a wave, so this wave has this much of path here. Like rope का जो length था, तो ये length जो है, ये rope हो गई. कितनी लेंथ है? 2 pi r. 2 pi r है ना? 2 pi r has to be integer multiple of the wavelength. Is should be equal to, एक मिनट ये ना थोड़ा यहाँ पे ही आ गया, तो दोबारा से कर लेते हैं. So 2 pi r जो कि लेंथ ऑफ द रोप था हैज टू बी इंटीजर मल्टीपल ऑफ वेवलेंथ. सो इंटीजर मल्टीपल ऑफ वेवलेंथ. अब वेवलेंथ क्या है यार? वेवलेंथ ऑफ मिस्टर de Broglie says is h divided by the momentum. That's what he says. So Planck's constant divided by the momentum. Momentum क्या है? Mass times velocity. अब इसको रीअरेंज कर दो यार. mvr इधर आ गया. mvr is equal to nh by 2 pi. Yes, you have already derived it. दो लाइन लगी तुम्हें सिर्फ, दो लाइन. So this is angular momentum and that is equal to nh by 2 pi. That's what Mr. Bohr said without proving or giving a reason for that. De Broglie is giving you the reason for that. ठीक है, अब इसको एक बार देख लो और इसको देखते हैं कि एग्जाम में कैसे प्रेजेंट करना है. पहले तो हमने ये समझ लिया, उसके बाद हमने 3 लाइन में कर लिया, फिर हमने देखना 3 मार्क का क्वेश्चन है. सो बेस्ड ऑन दैट यू आर सपोज टू राइट द नंबर ऑफ लाइंस, बिकॉज सी व्हेन वी आर डूइंग दिस वी आर थिंकिंग अ फ्यू थिंग्स इन आवर ब्रेन. नाउ यू हैव टू प्रेजेंट ऑल ऑफ देम. सो लेट्स सी हाउ यू डू दैट. Right, so this is Bohr's postulate and this is how you can write it. No memorization needed, no memorization. Simple. If you've understood it, you're supposed to be writing it in your own words, own language, own vocabulary, own grammar. That's all. So de Broglie wavelengths, that's all it is about. Bohr's hypothesis, postulates. So let's go to the next question here. Explain the process of nuclear fission and fusion by using the plot of the binding energy. We already did this. You're supposed to be able to present it yourself. You make that graph and then show, okay, when fusion is happening, 2 of the daughter nuclei, they're combining to form a bigger one, but now there is more binding energy. More binding energy means negative more. That means that overall mass has to be reduced. That loss in mass is what you get back as what you use. Sun is doing that. 2 hydrogen atoms combine into forming 1 helium and you get so much of energy coming to you for years and years, and it will be never run out for next I don't know how many billions of years. So radioactive, second वाला ये है. न्यूमेरिकल लगता है मुश्किल कई बार. रेडियो एक्टिविटी में आ गए है ना, ये क्या हाफ लाइफ 10 years, क्या 3.12, नंबर ही थोड़ा अगली सा है 3.12 है ना. बट यू रियलाइज 3.12% इज 1/32 एंड दैट गिव्स यू अ क्लू. फटाफट सोचना है उसको. ये देखो है ना, 1/32 क्या होता है, पहले तो मैं समझा दूं सिंपल तरीके से कैसे सोचना है, देन यू कैन, आई विल ऑल्सो शो यू हाउ यू कैन डू दैट इन एग्जाम. सिंपल तरीका क्या है यार, 1/32. व्हाट इज हाफ लाइफ? मेरे पास कुछ है ना, कंटेनर में न्यूक्लियर है, वो डिसइंटीग्रेट हो रही है बिकॉज ऑफ रेडियो एक्टिविटी. कितने टाइम में हाफ बचेगी? लेट्स से आई विल स्पीक दैट इन इंग्लिश आल्सो. लेट्स से आई हैव अ कंटेनर ऑफ न्यूक्लियर देयर, 1 million nuclei. So they disintegrate. After how long will that 1 million be? Half a million. That is called the half-life period. So let's say the half-life is 1 day. Tomorrow I come back same time, I will see half a million. Day after tomorrow I come back, it will be half of what was remaining. So that will be 1/4. है ना? Half बचा था. So let's see this. You had this here. So you had this container. By tomorrow, ये चली गई. These are gone now. By the next day, whatever was left, उसका हाफ चला गया तो 1/4 बचा. By the next day, 1/8 बचा. Now think about it. पहली हाफ लाइफ के बाद 1/2 बचा. If this was a competitive exam, you can do very quickly. 2 हाफ लाइफ के बाद 1/4 बचा. 3 हाफ लाइफ के बाद 1/8 बचा. 4 हाफ लाइफ के बाद 1/16 बचा. 5 हाफ लाइफ के बाद 1/32 बचा. तो 5 हाफ लाइफ हो रही है इधर. 1 half life is 10 years long, so 5 half lives are 50 आंसर आ गया इसका. ठीक है. एंड आई विल ऑल्सो शो यू हाउ यू कैन प्रेजेंट इट, बिकॉज बोर्ड एग्जाम में ये नहीं चलेगा, ये कॉम्पिटिटिव एग्जाम में चलेगा. बोर्ड एग्जाम में पूरे स्टेप्स दिखाने. सो लेट मी शो यू हाउ यू कैन डू दैट. आई विल वाइप आउट द व्हाइट बोर्ड एंड देन लेट्स डू इट अगेन. सो बेसिकली हाउ लॉन्ग विल इट टेक फॉर द एक्टिविटी टू रिड्यूस? तो ये तो तुम्हें पता ही है, activity is equal to activity naught at the beginning of all this. This was the activity. E to the power minus lambda t. ठीक है, ये तो पता ही होगा. This is the thing here, and we are going to derive this in upcoming question here. I think after this or the one after that. तो ये अब it's given, will it take for the activity to reduce to 3.12%, मतलब 1/32. That, see how easy calculations they are making for you. They're trying to check your concepts, not your mathematics calculation skills here. E to the power minus lambda t. अब देखो, अब क्या लगता है करना क्या है? For the students who are not mathematics students, looks like okay ये exponential ये सब क्या? It's very easy. Let me tell you. ये a0 तो कट गया. You don't even care about. This is 2 to the power 5, isn't it? So this is, I'm doing all the steps so that the biology students can also understand this. ये आ गया. अब ये नेगेटिव साइन गड़बड़ कर रहा है. सो यू कैन फ्लिप दिस. ये नेगेटिव साइन यहां लाओगे तो ऊपर 2 की पावर 5 चली गई. 2 की पावर 5 इज इक्वल टू ई टू द पावर माइनस लैम्डा टी. अब ये एक्सपोनेंशियल का क्या करना है? एक्सपोनेंशियल यहां के लॉग बन जाएगा, नेचुरल लॉग, कॉमन लॉग नहीं, नेचुरल लॉग. सो यू ब्रिंग इट हियर, दिस बिकम्स लॉग ऑफ 2 टू द पावर 5 इज इक्वल टू लैम्डा टी. ये पॉजिटिव हो गया क्योंकि आई हैव मेड दैट. ठीक है, लैम्डा टी. सो लॉग हो गया, इसके बाद हो गया लॉग 2 to the power 5 is equal to lambda t. अब lambda क्या होता है? lambda is log 2 divided by half life period. तो और ये 5 इधर चला जाएगा. 5 log 2 is equal to lambda की जगह लिख दिया log 2 by t half life, है ना? t half life वो जो 10 साल दिया है वो. अब log 2 कट गया. t half life 10 है. 10 into 5 50 बन गया. खत्म. इतना सा है ये. That's all. So let's see how you can present that for getting 100% marks over there. So this is what you're going to write. Nuclear fission समझा दिया, fusion समझा दिया. Right. So I'll move out here, I think, so that you can read it or take a screenshot if you have to. None of this has to be memorized. Everything has to be understood word by word. Understand करना है physics में. Memorization is not going to help you. You have to understand these concepts. And then presentation is up to you. सो ये है, ये ग्राफ ऐसे एग्जैक्ट बनाने की जरूरत नहीं है, रफली ऐसे बना दो. यू डोंट हैव टू रिमेंबर दीज. एक्चुअली जस्ट शो द फैक्ट दैट अप टू अ सर्टेन लेवल व्हिच इज एक्चुअली आयरन, यू कैन मार्क आयरन. आयरन तो सबको याद रहेगा, आयरन स्ट्रॉन्ग, आयरन शक्ति, राइट, बिकॉज इट हैज सो मच ऑफ बाइंडिंग एनर्जी. सो मेक ए ग्राफ रफ लाइक दिस एंड देन शो आयरन देयर, और उसके बाद देखो रिड्यूस हो रहा है. यू जस्ट रिमेंबर द आयरन सबसे ऊपर है. Now this is the thing that I was doing. I'll just move out here. So see how easy it is. And they're not saying 1/30. They're not saying 1/28. It's 1/32. क्योंकि 32 is 2 to the power 5. and when you take 5 it becomes 5 log 2, and see log 2 cancels out there. 50 years, 50 saal. So let's see the next question. Again, one of the questions that many students think, "Bhai, ye sab equations kya aa gaye?" This is very easy equation. Let's do that together. थोड़ा chemistry भी use होगा यहाँ पे, क्योंकि you have to remember these atomic numbers and all that. Question 1 says, write the basic nuclear process involved in the emission of beta positive by a radioactive nucleus. Look at the question one more time, because this question many students I have seen they make the mistake. They're not talking about what happens to the element as such. Many students start by writing X ka ye or it gives out beta. No, they are saying inside the nucleus. Abhi emit nahi hua hai. What is happening inside the nucleus? What happens inside the nucleus is this. Look, let's go back here. कहाँ गए? हाँ, ये रहा क्वेश्चन, ठीक है. सो लेट्स गो बैक इनटू द क्वेश्चन एंड इट सेज बीटा पॉजिटिव आता कहाँ से? पहले तो सोचो इलेक्ट्रॉन कहाँ से आता है. व्हाट इज बीटा पार्टिकल? इट्स एन इलेक्ट्रॉन. न्यूक्लियस डज नॉट हैव एनी इलेक्ट्रॉन आउट देयर. तो बीटा एमिशन हो कैसे रहा है यार? Remember, those electrons orbiting around, they are not participating. This is a nuclear phenomenon. So everything has to happen inside nucleus. Nucleus में neutrons और protons हैं. तो ये बीटा पार्टिकल कहाँ से आ रहा है? बीटा पार्टिकल आ रहा है क्योंकि बीटा पार्टिकल बनाया जा रहा है. Let's see how. So let's say there is a nucleus here. Let's first see beta negative and then we'll see beta positive. तो बीटा नेगेटिव कहाँ से आता है? बीटा नेगेटिव यहाँ से आता है. There are protons and neutrons. This neutron is going to break into a proton and an electron, and there are some more things, neutrinos happening there. We are not talking about that, but think about the conservation of charge here. It was a neutral thingy, it has converted into a positive and negative. Conservation of charge ho gaya, energy bhi conserve hogi with that neutrino coming out. But think about this now. There was neutron that breaks into proton and electron. This electron is what is beta negative, that is released now. So when there is a beta negative release, remember that, and this is not about this question, this is general information I'm giving you. Beta negative release हुआ तो क्या हुआ? Neutron kill, खत्म हो गया, proton आ गया. तो एटॉमिक नंबर इंक्रीज हो गया बिकॉज देयर इज वन एक्स्ट्रा प्रोटॉन इन देयर. एटॉमिक मास चेंज नहीं हुआ, मास नंबर चेंज नहीं हुआ, क्योंकि मास नंबर इज अबाउट टोटल प्रोटॉन्स प्लस न्यूट्रॉन्स. न्यूट्रॉन इज गॉन, प्रोटॉन इज बॉर्न. तो एटॉमिक मास विल नॉट चेंज, एटॉमिक नंबर विल गो अप, है ना, इसीलिए वो प्लस हो जाता है. बीटा पॉजिटिव का क्या है? बीटा पॉजिटिव की स्टोरी ये है, एंड व्हेन डज दिस हैपन, आई विल सजेस्ट दैट यू रीड इट, बिकॉज व्हेनेवर देयर इज एन इम्बैलेंस, मोर नंबर ऑफ न्यूट्रॉन्स हैं, then stability, then this happens. If the number of protons is more, this will happen. So what happens in this case is this converts into a neutron and a positively charged electron, positron, and this is the beta positive here. So look at what happened. Proton gone, it convert into neutron and positron. Think about the charge, positively charged body, टोटल पॉजिटिव वन चार्ज, कंजर्वेशन ऑफ चार्ज. एनर्जी भी कंजर्व हो गया. एनर्जी मास कंजर्व होता है, एनर्जी नहीं कंजर्व होती, एनर्जी प्लस मास इज कंजर्व. तो दिस इज द स्टोरी दे आर टॉकिंग अबाउट. Inside a nucleus, you're supposed to write for this. I'll show you the equation how you can present it. That's all. ये करना है बीटा पॉजिटिव. बीटा नेगेटिव पूछें तो ये दिखाना है कि न्यूट्रॉन ब्रेकिंग इनटू दैट. Now let's look into this. ये A B C D X Y Z क्या है? Y क्या होगा? दिस इज बोरॉन. यू आर सपोज टू नो बोरॉन हैज एन एटॉमिक नंबर ऑफ 5. तो यहां मैं 5 लिख देता हूं. अब अगर मैंने यहां 5 लिख दिया तो ये सोचो, है ना, ये तो न्यूट्रिनो है, भूल जाओ न्यूट्रिनो को. ये क्या हो सकता है? इज इट गोइंग टू बी अल्फा पार्टिकल, बीटा पार्टिकल, गामा रेडिएशन, बीटा पॉजिटिव, क्या है, कैसे होगा? सोचो इसको. एटॉमिक नंबर ऑफ प्रोटॉन्स हैव टू बी कंजर्व्ड. सो नाउ दिस इज 6 एंड दिस इज 5. यहां पे 1 बन जाएगा, इजंट इट? यहां पे 1 आना चाहिए क्योंकि यहां 5 हो गया, तो यहां पे 1 आना चाहिए. ठीक है, यहां पे 1 आ गया. अगर 1 यहां पर आ रहा है मतलब ये बीटा पॉजिटिव है ना. बीटा नेगेटिव होता तो यहां -1 आता, तो दिस इज बीटा पॉजिटिव. अगर यहां पे पॉजिटिव आया तो ये 0 हो गया फिर, क्योंकि उसमें न्यूट्रॉन्स तो हैं ही नहीं. अब ये 0 है तो ये 11 आ गया. बस ये तुम्हारा सोल्यूशन हो गया, पहला इक्वेशन हो गया. जस्ट बिकॉज बोरॉन इज 5, दिस इज सपोज टू बी 1, देन यू नो दिस इज नॉट हीलियम, दिस इज बेसिकली अ पॉजिट्रॉन. अब दूसरे पे आते हैं, दूसरा एनालाइज करते हैं. भाई क्या हो कह रहा है, 2 कार्बन कार्बन, ओके. तो मेरे को सपोज नियॉन का एटॉमिक नंबर नहीं पता, सपोज आई डोंट नो दैट. वैसे तो पता होना चाहिए पर नहीं पता. हीलियम लिख दिया उन्होंने. हीलियम क्या है यार, दिस इज सिंपली यू नो दैट दिस इज 2 4, you know that it's an alpha particle here. Now if this is 4 plus 20 24 match or perfect. Now this is 2, this is something I don't know, but this is 6 plus 6 12. तो ये 12 है तो इधर भी 12 होना चाहिए, तो ये मेरा 10 हो गया. बस यही करना है, XYZ ABC खत्म हो गया. सिंपल है, कुछ नहीं है इसमें, कुछ भी नहीं है. So let's see how we can present it. Here you go. So beta positive here, right? Beta positive क्योंकि यहाँ 1 चाहिए था, 5 यहाँ था तो 1 चाहिए था. 1 आया तो पता लगा अल्फा नहीं है, ये बीटा पॉजिटिव है, तो यहाँ 0 कर दिया, तो ये तो 11 पहले ही था, नथिंग टू बी डन. इधर क्योंकि हीलियम था, ये खत्म. Let's go to the next question here. State the law of radioactivity and hence show that. प्रूव करना है उसको. ये बना दिया मैंने, है ना. प्रूव करना है, क्या करना है, कैसे करना है, ये बनाया तो पता है कि पीस ऑफ केक है ना. खाना है खाओ, गिफ्ट करना है गिफ्ट करो. ना शो दैट. अब नाउ व्हाट इज द लॉ ऑफ रेडियो एक्टिविटी? लेट्स अंडरस्टैंड इन सिंपल वर्ड्स हियर. लेट्स से आई हैव ए कंटेनर विद न्यूक्लियाई, वो डिसइंटीग्रेट हो रही है. सिंपल वर्ड्स में बता रहा हूं, एंड देन आई एम गोइंग टू शो यू द प्रिंटेड वर्जन ऑल्सो. सो देयर इज अ कंटेनर विद न्यूक्लियाई and they are disintegrating. That's called the activity. Activity means kitna ke I have supernatural powers. I can observe that and I can say oh beta particle aa gaya, oh alpha particle aa gaya. They are disintegrating. So when they are disintegrating, I can see that okay, ये तो कार्बन था, अब ये कार्बन नहीं रहा, it has converted into another something. I can see that somehow I have that capability. So this is a container and I'm watching it, and I say there are 1000 nuclei here. ये चलेगी. तो देयर इज सम एक्टिविटी, मींस एवरी सेकंड हाउ मच इज हैपनिंग, और एवरी मिनट व्हाट इज हैपनिंग पर यूनिट टाइम यू कैन डिसाइड, सेकंड, मिनट, आवर, ईयर, व्हाटएवर. सो एवरी यूनिट ऑफ टाइम हाउ मच इज हैपनिंग इज कॉल्ड द एक्टिविटी. इफ देयर वर 1000 न्यूक्लिया हियर, देयर वाज सम एक्टिविटी, मे बी 2 every second. If I put 2000 न्यूक्लिया here, it will be 4 per second, क्योंकि डबल हो जाएगी एक्टिविटी, है ना. 10 गुना न्यूक्लियस डाल दी, इट द एक्टिविटी विल बी 10 times. तो क्या समझ में आया कि एक्टिविटी इज प्रोपोर्शनल टू द नंबर ऑफ न्यूक्लियाई इन देयर. दैट इज द लॉ दैट दे आर टॉकिंग अबाउट. एक्टिविटी इज प्रोपोर्शनल टू द नंबर ऑफ न्यूक्लियाई इन देयर. सो द रेट ऑफ डिसइंटीग्रेशन इज प्रोपोर्शनल टू द present number of nuclei there. Now with that you can derive this within 2 or 3 lines. Let me show you how. So what we are saying is the rate of disintegration, the rate of disintegration, यही तो हुआ. एवरी सेकेंड कितनी डिसइंटीग्रेट हो रही है, इज प्रोपोर्शनल टू कितनी है, इतनी है. दिस इज द लॉ वी आर टॉकिंग अबाउट. बट नाउ यू नीड अ नेगेटिव साइन देयर बिकॉज द चेंज इज नेगेटिव, कम हो रही है ना. So it's always we have to put negative there. Now whenever you remove this proportionality sign, you have to put some constant, and that is the lambda that we were using earlier. So dn by dt is equal to minus lambda of t. हो गया है ना, lambda of n. sorry. अब इसको erase करने की फैसिलिटी नहीं है, तो let me wipe this like this, lambda of n, है ना, n, this n. जल्दी में t लिख दिया. Now you can take this t there, n here, and then you can integrate. So what I get now is dn by n, and I'm doing with all the steps so that biology students can also figure out what's going on here. अब ये इक्वेशन बन गई. अब इसको क्या करना है, हमने इंटीग्रेट करना है. इंटीग्रेशन की लिमिट्स देखो क्या होंगे. इसको इंटीग्रेट किया कहां से, ओरिजिनली कितनी थी और अब कितनी है. लाइक व्हेन आई स्टार्टेड माय स्टॉप वॉच, हाउ मच वाज इट ओरिजिनली, दैट्स वेयर यू स्टार्ट. ओरिजिनली वाज n नॉट, नॉट सिंबलाइजेस द इनिशियल. अब टू अब कितनी है, अब n बची, दिस इज द लिमिट. अब इस केस में क्या इंटीग्रेशन लिमिट्स होंगी, t टाइम 0. व्हेन आई स्टार्ट द स्टॉप वॉच टाइम वाज 0. अब कितना टाइम है, t टाइम, t टाइम, हैज नॉट t टाइम बट t. लैम्डा बाहर आ जाएगा कि इससे कांस्टेंट, इंटीग्रेशन ऑफ डी टी इज टी, तो उसकी लिमिट्स रखी, टी बचा, इधर क्या बचा, लॉग एन, 1/n का इंटीग्रेशन लॉग एन, तो लॉग एन क्या आ जाएगा, एल है ना, उसकी लिमिट्स रखी तो n/n0 इज इक्वल टू लैम्डा टी विद नेगेटिव साइन इन देयर। अभी एक्सपोनेंशियल बन जाएगा, लॉग उधर जाके एक्सपोनेंशियल बन गया, n0 भी उधर चला गया, तो तुम्हारे पास ये आ गया। And that is it. I'll show you like once you understand this, you can write it in your own words, and this is what it is. The rate of disintegration of radioactive atoms present is proportional to how much you have in there. So dN by dt is proportional to that negative. Negative sign is really important because it is disintegration, कम हो रही है। बाकी तो तुम्हारा presentation skills है। Now we are going to meet tomorrow, and that is the last session we have. But before you leave today, please do subscribe to the YouTube channel. First of all, thank you so much for joining. I hope this was helpful. Subscribe to the channel, press the bell icon. Also download and install the app that was released recently, because all these slides will be in a PDF form in there. Make use of that. And please make sure you share all this information with your friends and whoever you want to help out get the free education here. I'm going to see you tomorrow, same time, same jagah. Okay, I'll see you tomorrow. Thank you so much. Bye bye.